Looking at chapter 6, additional mathematics, chapter 6, and the title of our topic today is logarithmic and exponential function. So this is called, for simple terms, it's called logarithm. Logarithm, okay, logarithm with m as the end, in the end. Okay, logarithm and exponential function. Exponent means indices. Exponential function means indices. So here we use simple properties of logarithm and exponential function, including in x and exponent x. Exponent x. So these are two concepts that we will be very familiar with, that we'll be using throughout this chapter. In x, which is ln x, and exponent x, e raised to power something functions. We'll be looking at them in this chapter. Okay, we'll also be looking at the logarithm graph, which is in x graph, and exponential graph, which is indices graph. Okay, and the graph of the differential part of this and the differential part of this, the graph of them. We're going to look at them. And then we're going to use the laws of, just the same way we have laws of indices, we have laws of logarithms. Laws of logarithms. When you hear log, log means logarithm. For short, we write log. LOG. For some textbook, we use LOG for short form. Some textbook, we just use LG. Some textbook use LOG like this as the abbreviation of log. Some textbook like this one use LG. Just LG for log. Okay? Okay, so these are the things we'll be looking at in the entirety of this chapter. We'll be looking at, one more thing we're going to look at is how to solve, okay, apart from use the laws of logarithm, including the change of base. We're going to learn about change of base of logarithm. Okay, this is one important concept in logarithm, the change of base. How do you change base of logarithm function? So how do we change base of logarithm function? But the last but not the least of the things we're going to look at throughout the course of this chapter is the how to solve the equations of the form of ax, a raised to power x, which is the exponential function, exponential equation. A raised to power x equals to b form of equation, exponential equation. If this one you've done, these are indices. This last part is indices. When you hear exponential, we're talking about indices. Now let's go to the very foundation of logarithm. What is logarithm? It's just an opposite of exponential function. Logarithms are opposite of exponential functions. Okay, now what are log to base 10? Just the way we have binary and decimal number. You know, decimal number, the base is 10. So in logarithm, one of the fundamental base is base 10. One of the fundamental base is base 10. Here are some key rules. Just the way you say to A is equal to 1. Log base 5 to 5 is equal to 1. Okay, if you have log 5, whether I write LOG for log or I just write NG for log, I said they are this 1. Okay, so this is one rule. The rule for base 10 is that log 10 is equal to 1. Okay, now what of log 10 1? Log base 10 1 is equal to 0. Log 10 1 is equal to 0. If log 10 equal to 1, log 10 1 is equal to 0. Okay, so log A1 also equal to 0. So if we write log A1, log one equal to 0. Log 10 1 equal to 0. Is that okay? Take note of this. Now let's go to the graph of exponential and logarithm function. Exponential and logarithm function. You know, exponent is when you take a number to power something, right? Exponent is when you take a number, let's say 5, you say to power x. This is exponential function. Or 10 to power x. This is an exponential function. Remember the graph when we do in ordinary maths chapter 18, when we did the graph, if you plot the graph of exponential function, it will be like this. the graph will look like this. Exponential function, the graph will look like this. It will be an increasing curve exponent. This is the graph of exponential function of this one. Let's take the graph of log 10x. Log 10x will be, this, okay, let's extend this. Let's make our graph for cardinal plane like this, okay. So the graph of this one will be like this, A curve going through this concept. This is the logarithm, which is opposite of this one, right? If you look at it, it's opposite of the exponential function. If you look at it, it's the opposite of exponential function. The exponential function is going like this, or more intensively going like this. Okay, we can wait. Let's make it more. This is exponential function graph. This is the logarithm function for graph, this one. So you can see they are opposite. And you can have a straight line graph. You can have a straight line in between them, like y equal to x. Y equal to x is this line, a straight line function. Y equal to x, gradient is this straight line. Assume this is a straight line. So this one is y equal to x, straight line graph. Y equal to x, and y this one is the logarithm function graph, y this one is the exponential function graph. Okay, so now let's solve examples, let's solve questions. Convert 10, this is an exponent, 10 to power x equal to 150 to logarithm function. Change it to logarithm function. And the second one, convert log 10x equal to 6.4 to exponential function. So they've given us two scenarios. They want us to convert one from exponential to logarithm, and they want us to convert the other one from logarithm function to exponential function. Let's start with the first one. 10 to the power of x, log 10. Log to base 10 to both sides. So we have to introduce log to base 10. So I will introduce, let's use another color to show something different. So we are introducing log 10, log to base 10 to both left and right. So we write log to base 10 here. Base means a little bit lower, right? Log to base 10, 10x. So now we write 10x. Log to base 10, 10x. Power it. You say 10 to the power of x is equal to, you also introduce log to base 10 to the left, right side. So it's equal to log to base 10, 150. Is equal to log to base 10, 150. So the only thing we just did here, log to base 10, then 150. Okay, we can continue with the same color, 150. So the only thing we did, this is the question. We introduced log to base 10, then we write whatever was given to us here, and then on the right we also introduce log to base 10. We have 150. So this is the first step. The second step in logarithm, when you have 10, 3 layer, see 10 is raised to power 10, then this 10 again is raised to power x. 3 layer up, like you're building a staircase. 10, this 10 is raised to power this 10, and then this 10 is raised to power x. In logarithm, when you have 3 layer like this, the last one can come as the exponential at the back here, can come and multiply. So this one will be, we come to the back, the third power will come to the back. It will become x log 10, 10. It will become x log 10, log 10, 10. And remember, the rule is that log 10, 10 is equal to 1. Remember that rule where we started. So this one will be equal to log 10, 150. This one is equal to log 10. Calculator process log 10, okay? When you press calculator log, every log, if you say log 5, it means log 10, 5. calculator is already programmed log 10, log to base 10. So when you press log 5, you know what you just told calculator? You are saying calculator process log 10 5. Like for example, if I press log 150 in the calculator, it means it's processing log 10 150 because calculator is already programmed on base 10. Okay? So the next step is that this one is equal to 1. This one, log 10 10 is equal to 1. So 1 times x is x. This one becomes x. So if you wonder why this one changed to x, it's because log 10 10 is equal to 1. This log 10 10 is equal to 1. And we started with that. Log 10 10 is equal to 1. Log 10 10 is equal to 1. So if that is the case, the whole 1 times x, we get x. So on the left is equal to x. On the right, we have to press our log 10 150. But you can leave it like this because they say change it to a logarithm function. This one is only showing that you've changed it to logarithm function. But if you want the final answer, you press your calculator log 150. Remember I said log 150 means log 10 150 because in calculator it's already programmed base 10. So when you just press log 150, it gives you log 10 150 and it will give you an answer. So in this case, we can stop here because they just say we should change it to logarithm function. X equals to log 10 150. That's our conversion to this one. Now let's go to the other one. They've given us logarithm, which we do the opposite. This question 1. Now in question 2, they've given us a logarithm. They want us to do exponent. They've given us logarithm. They want us to do the exponential function, convert it to exponential function. What's the logarithm function? They say log 10x, right? Log 10, log base 10x. You see, once you see log, it's already a logarithm function. So log to base 10x is equal to 6.4. They say you should convert it to exponential function. Convert this one to exponential function. So this one, what we do is that we extrapolate. We extrapolate. This 10 will come here and it will be 10 to the power of 6. And x will go back. Okay, x will remain here. The base of logarithm will be the base to which this number will be raised. Will be the base to which this number it will be 10 to the power of 6.4. To be 10 to the power of 6.4. Okay, we use this trick in some functions in ordinary IGCSE maths when they give you some function that you have to extrapolate. So this one will go this way to be 10 to the power of 6. Only x will remain here. Okay, only x will remain here. So this one will go this way. So x will be in your calculator 10 to the power of 6. This is exponential function. This is exponential. This is an exponential. Once you put it in this form, you've converted it to an exponential function. Now let's take a look at some exercise. Maybe that one will give you clarity. Convert from exponential form to logarithm function. So you already have this one. 10 to the power of 4 is equals to 1000. Right? 10 to the power of 4 is equals to 1000. Right? So how do we change this one? For this one, how do we change this following to logarithm form? So you introduce log 10 here, introduce log here, log 10, 10,000. Right? Then this one will go to the right. Let's say, for example, you have, okay, let's do this one first before we do this one. You have 10 to the power of x. 10 to the power of x is equal to 80. Is equal to 80. To change it to logarithm form, you write log 10 x equals to log 1080. Log 1080. Go to log. They want us to convert from this exponential to logarithm. So this s can come to the back. It will be x log 10 equals to log 1080. Okay? And this one, we can make s the subject. S will be, okay, this one we can make S the subject, or we can stop, which means we've introduced logarithm function already. We've introduced a logarithm function. Or if you want to go further, you say S log 10 is equals to log 1080. Is equals to log 1080. So this one you've already introduced a logarithm function. You've already introduced logarithm function because that's what they want you to do. To introduce logarithm. Same you do here. Log, you introduce log here. Log 10 raised to power 4 is equals to log 10,000. Is equals to log 10,000. Log 10 to the power of 4 is equals to log 10,000. Okay, they just want you to introduce logarithm to this. So equals to log 10,000. Okay, now is a solve of this equation. I'll give you an answer to 3 significant figures. Solve each of these equations, give you an answer. So this question, log 3, 1 over, all these things are not hard, okay? Log 3, 1 over, they're just trick you need to know. 1 over 243. 243. Now, 243 is 3 raised to power what? It's 3 raised to power 5, right? 243, if you do your cubic number, is 3 raised to power 5. 243 is 3 raised to power 5. How you know? 3 raised to power 3 is 27, right? 3 raised to power 4 is 81. 3 raised to power 4 is 81. 3 raised to power 5, we give this one in cube. You can try it with your calculator. 3 raised to power 5 will give you this. So instead of writing 343, I write 3 raised to power 5 here. So this will become log 3. This will become log 3 1 over 3 raised to power 5. And you know in indices 1 over, or logarithm 1 all over means we write this number raised to power minus 5. This one will become 3 raised to power minus 5. I can change this one. You remember indices, right? Power number. This one will be 3 raised to power negative 5. So I can rewrite this to be 3 log 3. This one will be log 3, then 3 raised to power negative 5. 3 raised to power negative 5. Remember this in indices when we say 1 a raised to power minus 1 in indices. When we say a raised to power minus, okay, let's say a raised to power minus 5 in indices. This will be 1 over a raised to power 5. Am I right? This will be 1 over a raised to power 5. That's the logic we did here also. So when something is 1 all over, or something over a raised to power 5, or something over 3 raised to power 5, 1 all over 3 raised to power 5, you see it? Take a look at this. It's just like if I give you 3 raised to power minus 5 in indices, it can be written like this. This one can be written like this. 1 over 3 raised to power 5. 1 over 3 raised to power 5. In indices, you've done indices severally. So that's when we have this, we change it to this format. Minus 5 will go to the back, become the coefficient of log. We come here. This will become negative 5 log. You go to the back of log. This one, negative 5 log 3 3. Negative 5 log 3 3. This one comes here. It becomes negative 5 log 3 log base 3 to power 3. To be negative 5 log base 3 to power 3. Remember, log 3 3 is equal to 1. Remember, log 3 3 is equal to 1. So 1 times negative 5 times 1 will be negative 5. So our answer to this question will be negative 5. Negative 5 times 1 will be equal to negative 5. Will be equal to negative 5. Okay? So our answer is 5 for this question. Okay? For this one, this is how they got 3. Okay? So here you can pause and do some calculation. Convert from exponential to logarithm. Just add log 4, 2 equals to log 16. 2 goes to the back, become 2 log 4 equals to log 16. 60 is 4 power 2, right? Or you leave at that because they just say you should convert. 3. So you bring 3 back, log 3, say convert the following logarithm to exponential. Okay, to logarithm to exponential. This one you extrapolate. This one will be 3 raised to power 27. This one will be 3 raised to power 27. Finish. They say convert to exponential. This will be 3 raised to power 64. This will be, so if you are converting. But if you are solving, if you want to prove that this is equal to 3, 27 is 3 raised to power 3. You break 27. It's 3 raised to power 3. The highest power of the 3 will come to the back to become 3 log 3. Log 3 here will be 1. 1 times 3 will be 3. The answer here, that's why it's 3. Now, this one they say solve. Okay? Solve. Log 2x equal to 6. So you do extrapolation. X will be 6 to the power of 2. X will be 6 to the power of 2 and x equals to 36. You do extrapolation. X will be 6 to the power of 2. If you're solving this one, this base will come here. X will remain here. This log will be changed to x. If you are changing to exponential, x will be equal to, you see this base will come here to stay here. It will be 6 to the power of 2, which is 36. Okay, same here. This one, 2x plus 1 will be equal to 5 raised to power 2, which is 25. Then you solve the simple equation. This one will remain 2x plus minus. The mathematical concept is the same. Okay, so this is the second law of indices. Now let's go to third law. Third law says when you have, just like power law in indices, third law says when you have log base A, x raised to power m, you know I've been using this technique, x, and then there's another level of power, meaning 3 layer. You can see 3 layer raised to power m. This m should go to the back. This m should go to the back. So this will become m log ax. This will become m log ax. M log ax. Okay, this is the third law, which is the power law. This is the third law of indices. Then the fourth one is the fourth law of logarithm, not indices, logarithm. The fourth law of logarithms is that if you have log base a raised to power log, you have this will produce negative, because this will be log a, this will be log a x, or raised to power x raised to power minus 1. Log a x, you know in math sometimes we don't write the 1. So this will become minus, instead of writing minus 1, just say minus log this is very important, put it down, minus log ax. You can say minus 1, there's nothing wrong, okay, if I put minus 1 here. Then minus 1 is just simple as saying minus ax. Minus log ax. Okay, so that's the fourth law. So this fourth law, let's hold on to them very dearly, and they're going to help us a lot. Now let's solve an example. If you are given log 7 plus log 3, using the laws of indices, let's simplify some of these questions. We have 3 questions to simplify. Now, remember, we say whether they write log base 10 7 is same thing. Log 7 or log base 10 7 is the same thing. Okay, so log 7, you just write log, you open bracket 3 times 7, which is 21. So you write log 21. You write log 21. Okay, you write log 21. Please write it down. If you don't write, you don't get it. If you don't write, you think you are just listening, you don't get it. Okay, so if you are giving log 7, you just say log, you just write log. Since they both have log 7, log, you just write log 7 times 3. Log 7 times 3, which gives you log 21. Which gives you log 21. So, you know, you can evaluate this in calculator. Log 21, press calculator to give you a value. Okay, however, you can just stop here. Now, it says simplify this one also. Log 3, 80 divided by log 3, 3. So, since they have the same base, you can see they have the same base, which is base 3. So, you should just write log 3. Like you factorize log 3 out. You know that kind of thing? In algebra, it's like you factorize log 3 out. Log 3, 80 divided by log 3, 3. This is a mistake, okay? This is 3. This place. Let's correct it. It's a typo error from the textbook. There is no log 4. If you look at the question, there's no log base 4. It's log base 3. It's a typo error. You should see it when you should recognize it when you see one. Okay? If you are good in it, you recognize it. So you can see log base 3. Look at the question. Log base 3, log base 3. Log base 3, 80 divided by log base 3, 3. So since log base 3 is common to both one, you just write log base 3, like you factorize it out. And since this is division, you have to, since this is okay, I think this is supposed to be minus. Also, there's a mistake here. Here it should be minus, not division. Here should be minus. So when it's minus, then we divide 80 divided by 3. 80 divided by 3. All this type of thing we are supposed to be informing the author. Okay, we're supposed to be informing. I think they've come up with the newest edition. I think they've corrected all these mistakes. I think the newest edition I saw last time, these mistakes were no longer there. Okay, I think they were highlighted already. And okay. So since this is minus, you divide. Since this is minus, you divide. This is minus. Then you divide. You say log 3, 80 divided by 3. Log 3, 80 divided by 3. Then you get log 3, 6. You get log 3, 6. You stop here, okay? 80 divided by 3 is 6. You can just stop here. You don't have to reach. Now let's take a look at this. Take a look at this. You say 3 log 7, 2 plus 4 log 7, 3. 3 log 7, 2. So this one, what do we do? Plus means multiplication. We go to multiply. But before we do that, you do third law, power law. You move this 3 to come here. It becomes 2 to the power of 3. Okay? It will become 2 to the power of 3. So this will be log 7, log 7, log 7. You see this 3? You first write this 2. You know this log 7, 2. This 3 will come. You know, we brought it from the top here to the back. So you take it to the top here. This one will be 2 to the power of 3. Right? Log 7. 3 to the power of 4 is 81. So we can simply say log 7, log 7, 8. Now at this junction, you factorize log 7 out and then you multiply these numbers because it's plus. Plus means multiplication. So you just say log, this will be log 7. You write log 7. You write log 7 like you factorize log 7 out. Log 7 is common to both. So you say log 7, then you multiply these numbers. It's 48, right? So you say log 7. 8 times 81. 648. So you say log 7, 648. You stop there, okay? See another typo error from Log 7. 3 times 5. That's log 50. Finish. That's the log 100 is 2. Answer will be 2. But you can stop at log 100. Okay, this one, you bring this 1 over 3 to this power, which is minus 3. It will be 64 raised to power negative 3. And then this one will be log 4, 2 raised to power 2. This one come here. Then you multiply. Okay, they're easy. You pause the video and solve them. This one will be log, since it's division, to be minus log a. We're going to stop at this one, solve the logarithm equation. We're going to solve this one, and we're going to stop at this one. So to solve this one, remember, we're going to apply the law. We're going to apply the law. This, if you look at this place, what we see is second law. We can apply second law here on the left. And then the power law, we can apply the power law here on the right. Okay, we can apply the power law here on the right. Now let's deal with that first quickly for a moment. So this one will be log x. Since they both have base x, you just write log base x, write log x, then this is minus, you're going to have the same base. They both have what? The same base. We're going to factorize this base s out. You're going to factorize it out. So when you do that, you're going to have, it's like they're going to cancel each other out, and something like that. They're going to cancel each other out. So here you have 16. You understand what that means, right? When you have something on the left and right, they can cancel, which are same, they can cancel each other out. So here we therefore have 16. 32 divided by 2, I have 16 here, is equal to x squared. So if you find the square, take the square root of both sides, you get x equals to plus minus 4. S equal to, you take the square root of both sides, x will be equal to plus minus 4. But negative 4, we truncate. That's what the negative number we truncate, and we keep our answer as only 4. We keep our answer 4. Our answer will be equal to 4. Okay, so that's how we do this type. So here, you're going to pause and do. See, they both have the same base. So this one can cancel this one. Then you have 5x equals to 2x plus 9. Bring this one here, you have 3x equal to 9. Divide both sides by 3x equal to 3. We solve this one. Okay, they have the same base. The base on the left, we can cancel the base on the right. Because this is equation, remember that. This is equation. Log base this and log base this can cancel each other out. You just equate this to this and you solve. Is that okay? So pause the video and solve as many questions as question. Now solve this equation. 25 raised to power s minus 3 times 5 raised to power s equal to 0. So what we do, 25 can be broken down as 5 raised to power 2. 25 is 5 raised to power 2. So we break 25, we write 5 raised to power 2, and then raised to power x, raised to power this x, minus 3 times 5 raised to power x equal to 0. Okay, here we have to equate to 0. We say equal to 0. Equal to 0. Equal to 0. It's just a logic to make them this and this same. It's the same thing. Whether you say 5 raised to power x then multiply by 2 or 5 raised to power 2 multiplied by x is the same thing. Okay, so the logic is to enable me to define this one. Assume it to be y. 5 raised to power x equal to y. So this one will automatically become y squared minus 3 times y, because 5 raised to power x is y. Become minus 3 times y equal to 0, right? And there's something before you solve, you go further. Before we go further, remember that if you have y exponent, y equals to a raised to power x, the logarithm of x will be a raised to power y, to be equals to log a raised to power y. It will be equal to log a raised to power y. If you're looking for x, this will be x will be log of a raised to power this y. If you are making this one the subject, okay, a logarithm. This is like, so you see this one, after you substitute this equal to 0, you replace 5 raised to power x to be y, and here also y, you have this simple factorization quadratic function. Say y, there will be no solution. There will be no solution. 5 raised to power x equal to 0. This one has no solution. Then let's do the second one. You say y minus 3 equal to 0. The second one, equate this second one to 0. The same way you do quadratic. This y minus 3 equal to 0. Okay, so you say y minus 3 equal to 0. Okay, at this point is equal to 0. Let's write 0 here. It's still equal to 0. It's when we move the 3 to the right, it becomes equal to 3. Okay, now 5 raised to power x minus 3 equal to 0. And then you have 5x, only this one, equal to 3. Because you move this negative 3 to the right, equal to 3. So the next thing is to take log of both sides. You say log 5x equals to log 3. Log 5x equal to log 3. Why we take log? So we can find x. Because you can see this exponent. Log 5x equals to log 3. So this one will come to the back. It will be x log 5. This will be x log 5 equals to log 3. So you divide both sides by log 5. Divide here by log 5, divide here by log 5. So if you divide here by log 5, only on the left, only x will remain. Only this x will remain. So divide here by log 5, it will become log 3 over log 5. So if you key in your calculator log 3 divided by log 5, you get 0.683. And that's your solution. With this, we come to the end of our today's class. Please pause the video, solve all these questions. Solve all these questions as many as you can. Okay? Solve them as many as you can, and that will give you a better clarity of what you've done. Thank you for joining us.